Hello everybody. So in this video, I'm going to go through a couple examples for you and explain the formula for surface area for pyramids and cones. Then you're going to see another video that deals just with volume, and then I'll talk about spheres in a pretty short video after that. If you are feeling good after watching those couple videos, you don't necessarily have to watch the one that has the practice problems in it, but as always, you definitely can if you wish. Okay, so let's go ahead and jump right into it here. So in this video, like I said, we're going to talk about surface area of pyramids and cones. Okay, and the formulas are very similar for pyramids and cones, right? Cones are essentially like circular pyramids. Okay, so just as a reminder for you, a pyramid is different from a prism because a pyramid has only one base, which you can see in the two example pictures, as well as the nets that you see on the screen, right? Where you have the one base, right? And then the other faces, so this is another difference, all the other faces are triangles, and they're all typically congruent triangles, unless you're dealing with like a rectangular pyramid, for example, then some of the triangles are going to be different shapes, okay? But they're all triangles, okay? So the formula to find the surface area of a pyramid, remember, is the same as finding the area of its net, right? So we have capital B, which is the area of the base shape, which in some of these nets is like marked in blue, other than this hexagonal pyramid down here, okay? And then the other part here is the lateral area. Okay, so this right here is the area of all of those triangles. Okay, so in this tetrahedron, it's the area of these three other triangles combined. In this, a tetrahedron is just a special name for a triangular pyramid, where you have all equilateral triangles here. Okay, in this square pyramid, it would be the area of all four of these triangles combined. In this hexagonal pyramid right here, it would be the area of all six of these triangles combined. Okay, now there's a couple of terms here that may look a little bit like not familiar to you, and the main one that I want to talk about here is slant height. Okay, so normally when we're talking about the height of something, right, it's a vertical height. It's straight up and down. Okay, the slant height would be like if you say we're like walking up a hill, the slant height would be the distance that you actually walked like up the hill from the bottom to the top, right? Rather than the actual vertical distance that you traveled up, right? It's different than the altitude, okay? So another way you can kind of think about this slant height is it's like if you were like sliding down something, right? The slant height is literally the slanted or like diagonal height, basically, of a pyramid or a cone, okay? Another way you can think of it is that the slant height is like the height of each of these individual little triangles, right? Here, 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 and here, right? Which you can see a little bit easier if you look at this like forward example right here. So if this is my triangle, right? The slant height is right here, okay? Which if you kind of turn the triangle, this triangle on its side so that it's facing you, the slant height is right here. So it's like the height of this triangle, okay? So in looking at the actual formula for the area of all of those triangles, I'm hoping that that looks kind of familiar, right? It looks a lot like just how we find the area of any triangle, right? So just as a reminder for you, the area of any triangle is 1/2 the base times the height, okay? Well, I have the 1/2, right, in both of these. L is the slant height, right? That is the actual height of all of these triangles. And then B here the base is replaced by the perimeter of the base shape, which again, I'm hoping kind of makes sense, right? Because if we have the perimeter of, say, this square right here, okay, that's just all of the bases, right, of each of these triangles added together, right? So this, the 1/2 perimeter times the slant height, allows you to find the area of all of the triangles that make up the rest of the pyramid at once, right? Because this P right here is basically all of the triangle bases, right? So very similar, right? Very similar to what you've already seen in format, basically, of the area of a triangle. Okay, all right, so let's go ahead and I'm going to do a forwards example where I actually want to find the, where I actually want to find the surface area here. And then I'm also going to do a backwards example for you. Okay, so here in my forwards example, right, I'm going to use my my formula over here. Okay, so one of these things is pretty easy to find. It's the area of the base shape. Okay, because this is a square pyramid. Okay, so the area of the base shape is the side length squared, right? So 7 times 7, okay, which is 49. Okay, so that's the area of my square at the bottom. Okay, I can pretty easily find the perimeter of the base shape, right? Because it's a square, so it would just be 7 plus 7 plus 7 plus 7, right? Or you could do 4 times 7, okay, which is 28. Now, the thing that's going to be a little bit tricky is the slant height, because notice they gave us the actual height, like the vertical height, but they didn't give us the slant height of this pyramid. Okay, but what I'm hoping you can kind of see on here is this right triangle. Okay, that kind of goes through like the right half, basically, of this pyramid, right? So I can think of this as a triangle. Oh, hold on, let me change my color there. That's almost impossible to see. Okay, so I can think of this as a right triangle where I'm looking for some information, where this would be like A, this would be B, and this would be C in the Pythagorean theorem. Now, A right here is going to be half of this side length right here, right? Which is what this says here, right? Because the right triangle is basically going from the height, which goes straight through the middle of the pyramid over to the right edge, right? So it only takes up half of the side length down here, right? So that's 3.5, and then I know that B is 11. So I'm going to plug that information into the Pythagorean theorem. To help me find my slant height. Okay, so let's go ahead and do that. So I have 3.5 squared plus 11 squared equals C squared. Okay, so once I get to that point, I'm going to plug that information into my calculator. So 3.5 squared is 12.25. Okay, and then 11 squared is 121 equals C squared. I'm going to add those together. Okay, and I get that C squared equals 133.25. And then I'm going to take the square root of both sides to get C by itself, which is my slant height. Okay, and so I got that value was 11.54. Okay. Now I'll tell you, in most of the problems that I'm going to have you do, I'm not going to ask you to do this. Like a lot of the times I will give you the slant height that you need. I just want to make sure that you know that you do have the tools. If they don't give you the slant height, you do have the ability and the tools to help figure that out. Okay. Which almost always is going to be the Pythagorean theorem. Okay. So now that we have all the information we need, I have the area of the base, I have the perimeter of the base, and I have the slant height. Those are the three things that I need. So my surface area is the area of the base shape, 49, plus 1/2 times the perimeter of the base shape is 28, times the slant height is 11.54. Okay, so I'm going to deal with this part here first. So if I take 28 and I cut it in half, that's 14, right? And so then I would do 14 times 11.54. So when I did that, I got 161.61. You may have gotten a slightly different number than I did if you rounded a little bit differently than I did, which is fine, okay? And then I'm just going to add 49. So I get for my final answer 210.61. And then I need to make sure I include my units, which would be inches squared here. Okay. All right. So that's a typical like 4 words example. Okay. And then let's do one more where we're going to work backwards. Okay. So this time they gave me the surface area. They also gave me the slant height. It's in the picture. So that 14 is my slant height. Okay. And then they gave me the area of the base shape is 43.3. And they would like us to find the perimeter of the base shape. Okay. So remember, I'm still using this formula. Surface area equals the area of the base shape plus 1/2 perimeter of the base shape times the slant height. So let's plug in the information that we have. So 253.3 is my surface area equals the area of the base is 43.3 plus 1/2 times the perimeter of the base shape is what I don't know, but I do know the slant height is 14. Okay, so now this becomes an algebra equation that I need to solve. So the first thing I'm going to do actually is I'm going to subtract 43.3 from both sides because that's the first thing in my way. Okay, so I end up with 210 equals 1/2 times 14 times the perimeter. Okay, and I'm going to help myself out and say, well, 1/2 of 14 is 7. So I end up with 210 equals 7 times the perimeter. I'm going to divide both sides by 7. So I get that the perimeter is 30. All right. And I know they say they give you this cubits unit in here. So you could put that as your unit. But honestly, I just wasn't able to crop it out when I was creating this for you. Okay. All right. So that is pyramid surface area. All right. So give me just a second to clear my screen, and then we're going to look at cones. So I'll see you back here in just a second. All right, folks, so let's briefly talk about the surface area of cones. Okay, so very, very similar, okay, to the surface area of a pyramid, right? It's just because we're dealing with cones that we have a special formula that deals with like your radius and your slant height and stuff, right? Like that. But it still is essentially the general formula, right? Because remember, the general formula is the area of the base shape plus the lateral area, right? So here, pi r squared is like the area of the base shape, right? Because the base shape is a circle, right? Okay, and then the lateral area is the area of this this kind of curved, it's almost like just part of a circle. Okay, so this would be like my lateral area right here. Okay, so on my net, okay, obviously I have my radius here. Okay, and then I have my slant height, okay, which is here. Okay, so the reason why pi r times the slant height gives us the area of this kind of curved like part of the circle, it kind of goes beyond the scope of this like course, like this geometry course. If you're curious about why this works the way it does, like why pi times the radius times the slant height gives you the area of this part of the net, you can definitely look that up, or send me a message. Let me know that you're curious about that, and I can definitely explain it to you. But for now, just trust me that that if you want to find the area of this curved part, it's pi times the radius times the slant height, and then obviously the area of the circle at the bottom is pi r squared. Okay, so let's do a forwards example. Okay, this is a very nice forwards example because I gave you the radius and the slant height. Okay, so we're just going to plug the information we have directly into the formula. So my surface area is pi r squared plus pi r L. Okay, now very similar to other problems we've done and other formulas we've worked with that have this pi in it, okay, we are going to kind of leave the pi by itself and not multiply it through until the very end, just because it's going to make our life a little easier. Okay, so for this problem, my radius is 5 and my slant height is 8. So I have pi times 5 squared plus pi times 5 times 8. Okay, so I'm going to go ahead and deal with the numbers part of this. So 5 squared is 25. So I have 25 pi plus 5 times 8 is 40. So this is 40 pi. And then I'm going to add those two together. So I end up with 65 pi. And then once I get to this point, then I'm going to plug the information into my calculator and do 65 times, and then I'm going to hit my pi symbol to get my exact number. And then I'm going to click equals, and I get 204.20. When I plug that into my calculator, and then I need, my one last thing I need is my units, and that would be inches squared here, because even though this is a 3D figure, we are still dealing with an area. All right. Okay, one more here, and we're going to do a backwards example. Okay. So with my backwards example, they gave me the surface area and they gave me that the radius was 6 and they want me to find the slant height. Okay, they didn't give me a picture here. I don't necessarily need one, but you can always draw one if you're not exactly sure. Okay, right, you can always draw one. Okay, so I'm looking for the slant height. I don't know what that is, but I do know that the radius is 6. Right? So if that helps you to have the little visual, you can definitely draw it in there. But for this one, you don't necessarily need it if you know the formula. So I'm still using the same formula. Surface area equals pi r squared plus pi r L. Okay, I'm going to plug in the information that I have. So 301.44 plus, not plus, oh my goodness, sorry, equals. Okay, I have pi times, and this is 6 squared plus pi times 6 times the slant height. Okay, so I'm going to work with as much of this as I can and simplify as much as I can. So 301.44 is, so this is 36 pi plus 6 pi times the slant height. Okay, now what I'm going to do first actually is divide both sides by pi. Okay, just so that I can get rid of the pi in both of these terms right here. Okay, so I'm going to do 301.44 divided by pi. Okay, and I'm going to round because this number is rounded a little bit. So I get 95.95. So I'm going to round that up to 96. Okay. So that gives me then, that's 36 plus 6 times the slant height. And then I'm going to subtract 36 from both sides. Okay, so I end up with 60 equals 6 times the slant height. I'm going to divide both sides by 6 so that I get that the slant height is 10, and it would be 10 centimeters. Okay, now I rounded right here at this step. Okay, if you didn't round right there and you went ahead with 95.95, you would have gotten a slightly smaller number than I did, but not that much. Okay, most problems where you have to work backwards, if you end up having to do some of this division, like the dividing by pi, then more often than not, you are able to round up to a whole number. Right? Okay, so that is it for this video on surface area of cones and pyramids. Very much like the prisms, surface area is much more complex than volume. So the next video will be a little bit shorter, mostly because the formula is a lot easier to work with for volume, right? So I will see you in the next video. Bye, everybody.